Stanford University.
Welcome to lecture number 8 of CS193P. Today's lecture is going to be mostly demo. I'm going to do a little bit at the beginning, talking about one new concept. The rest of the time, this is going to be demo crazed lecture. So the thing I'm going to talk about first is gesture recognizers. This is the input side of writing a view. We talked last week on the output side, doing your draw rect, to get output on the screen in your rectangular area that your view manages. And this is how to get input in, swipes and pinches and pans, things like that. So we're going to talk about how you implement that. And then the demo today is going to cover I'm going to try and kitchen sink everything in that we talked about this week. We'll make a universal application out of our psychologist. We'll make it work on the iPad. I'll handle a pinch gesture so you can see how gestures work. I'm even going to go show you how to do this should auto rotate thing to make it so that your UI can react to being rotated and try and rearrange itself to look decent in the new orientation. And so it's a long demo. Hopefully, because it's kitchen sink, I won't mess up too much in one place or another. It's very hard up here. Obviously, one stray character and you're in the debugger, but hopefully that won't happen to me today. All right, so let's talk about UI gesture recognizer first. So this is the input side of touch events. Right? We're talking here about touch events. There are other events, by the way, that can happen in your application. Something might arrive for you on the network or something like that. But here specifically we're talking about the user making a gesture with their fingers, usually or often multiple fingers. Now there is a kind of a raw API for just finding out when a touch goes down and when a touch moves and when a touch goes up. And you can program to that level to handle input in your view, but we're not going to do that in this class. Okay, the gestures are better for two reasons. One, they're really easy to implement, as you're going to see today. And number two, the gestures would be standardized. You wouldn't want to write your own gesture to do a swipe, and then it turns out that you recognize a slightly different swipe than other programs recognize, in terms of duration or speed of swiping. So we want all the apps to be the same in terms of what it means, what a swipe is, what a pinch is, what a rotation is, etc. So gestures are handled in iOS by this class called UI Gesture Recognizer, but UI Gesture Recognizer is an abstract class. Okay, you all should know what that means. That means you never actually instantiate a UI Gesture Recognizer. It has a number of concrete subclasses that you instantiate, and that's what you use to do the work. Okay, but we do inherit some good stuff from UI Gesture Recognizer, the abstract superclass, and we'll talk about that. So there's really two parts to making a gesture recognizer work. First, and you don't have to do it in this order, but the two parts are adding a gesture recognizer to a view. So a view has a method called add gesture recognizer, and you add an instance of a concrete subclass of UI gesture recognizer, and now that view will handle, recognize that gesture. That gesture starts to happen in your view's bounds. It will handle it, right? But then number two is actually handling the gesture. So the gesture starts to happen, okay, or the gesture happens and continues to happen, like it's a pinch and it's pinching in and out and in and out. As it does, somebody's got to handle, what do I do in my view when that happens? So there's two parts, adding it to the view and then implementing the gesture recognizer. So we're going to talk about both sides of that. Number one, the adding it is often done by a controller. Okay, it could be done by other classes. The view actually might add a gesture recognizer to itself, and it would do that if this class just doesn't make any sense without that gesture. Okay, so there might be some UI classes where, like a button, if you couldn't tap on a button and have it do something, it wouldn't even make sense. It wouldn't even be a button. Or a slider, you couldn't drag along the slider. So I don't know how those are implemented internally, but if they're using gesture recognizers, those are added by the view itself. No one externally has to add the gesture recognizer because that gesture is fundamental to that view. But a lot of views, gesture might make sense or might not. You might want to enable it or not. And often it's the controller in an MVC that's making that decision for its views by adding a gesture recognizer to its view to one of its views when it wants to do it. Number two, which is the implementation of the handling of the gesture, when the gesture is starting to happen, who deals with it, that is very often provided by the view. Okay, so the view usually has an idea of what a swipe would mean inside of itself, or what a pinch, and so it's going to provide the method that is used, that's called, when a swipe or a pinch or whatever is happening. Now, again, it doesn't have to, though. Other classes could implement the handler for the gesture, but most of the time it's the view. Now, a view may implement a handler for a gesture, and then no one, in a particular application, no one adds a gesture recognizer for that gesture, and then that handler never gets called. Okay? So there's two parts. There's recognizing the gesture and handling the gesture. So let's talk about the code that you would write to add a gesture recognizer to a view from a controller, which is the way I said it's usually done. So a lot of times you're going to do this in view did load, because you're talking about sending a message to one of your views, the controller's views, to do something, and that view doesn't even exist until view did load has happened. And if the view got unloaded, then the gesture recognizer and everything would all go away, and then if it got reloaded, you'd want to add the gesture back. So view did load is a good place to add gesture recognizers. So what does that code look like? So let's imagine we have a view in our controller's capital V view, and it wants to recognize panning. So panning is when your finger touches down, you move around, then you let up. And while you're moving around, the view is panning around. Okay, it's moving something or moving around in the space in the view. That's what a pan is, okay? So we have this view, pan view. So all we need to do is create a UI gesture recognizer, but again, we have to create a concrete subclass. There happens to be a concrete subclass called UI pan gesture recognizer, exactly what we want, and we just alloc init it. The init takes two different arguments. The first argument is the target object to ask to handle this gesture when it starts happening. And the second argument is the method to send to handle the gesture. So the gesture recognizer uses target action to get its gestures handled. So when a pan gesture starts happening, it's going to start sending this action to the target, saying, pan gesture is happening. And it's going to go through various states, which we'll talk about in a second. So that's how it works. It's target action. And yes, it is possible to actually have multiple target action pairs. So you could have two people watching this pan happening. That'd be kind of weird. You want to make sure they don't interfere with each other, but you could do it. Very rare. So that's setting up the gesture recognizer and its target action. Then the only other thing we need to do is add that gesture recognizer to the view. So notice I'm sending this message, add gesture recognizer to the pan view. That's some view in our view hierarchy. And I'm just passing the argument pan gr, which is the pan gesture recognizer we created on the previous line. As I said, this is kind of like turning the gesture on. If you don't do this add, even if pan view implements that pan : method right there, it's still not going to pan. You have to add the gesture recognizer to the view. It has a list of gestures which it'll recognize. You got to add it or it just won't do anything. Okay? Pan : will never get called. Also, I think earlier in the slide, I said that pan : is a method on pan view, and so the target is pan view, but it could be another object. It could even be self. You could say gesture recognizer alloc init with target self, and then action some method in the controller. That'd be rare, but you could do it that way. Perfectly reasonable. One more line of code in here, though. Memory management. We now release this gesture recognizer here. Do you see why? Because we alloc initted it. That means we owned it. We added it as a gesture recognizer to the view. Presumably it took ownership. But we're not going to send any more messages, so we got to release it. So we're releasing it here. Everybody okay with that we're releasing it there? All right. So this is a little bit of a summary. Only UI view instances can recognize a gesture. And that's because UI views handle all touch input. That's what UI views do. They handle touch input and they draw. That's what UI views do. But any object can tell a UI view to recognize a gesture by adding a gesture recognizer to that view with add gesture recognizer. And any object can handle the recognition of a gesture. It doesn't have to be the view, but usually the view is the one who provides the handler, like pan : Everybody cool with that? Yeah.
So if it's the controller that that's the action.
Yeah, the target action.
We call init with target self.
Yeah. So the question is, if I were to have the controller itself be the one who's handling this gesture, would I say init with target :self action : some method in my controller? And the answer is yes. That's exactly what you would do. Okay. All right. So we've got this pan : How do we implement pan : Okay, pan : is going to get sent to us when a pan gesture starts happening. It's kind of magic to us. Somebody wrote that concrete class, UI pan gesture recognizer. We don't really know how it's happening, but somehow inside of it, it's watching touch events and it decides a pan gesture is happening. Okay, and then it's going to start calling pan : on us. So how do we implement pan : when it starts getting sent to us, usually in our UI view? So the way this happens is each concrete subclass, like pan gesture recognizer, provides methods that are specific to that kind of gesture to give you the information you need to write your handler for that gesture. So for pan gesture, for example, it provides 3 methods: translation in view and set translation in view, and we'll see why you need both directions there, and also velocity in view. So what translation in view does is it tells you how far this touch has moved since either since the start, since the gesture started, or since the last time it was reset with set translation in view. And then velocity in view tells you how fast that thing is moving in each direction, X and Y. Okay, so that's kind of fun. So the pan gesture, you not only get to find out where it is, but also how fast it's moving. And notice that it does have translation in view : and you pass a view. That in your implementation, usually the implementer is a view, and it's just going to pass self there. But again, if somebody else, like a controller, were implementing this, it needs translation in view : it needs to specify the view coordinates in which it wants to get that translation, right? So that's why that extra argument is there. Some people get confused by that. But there's another method that is very important to implementing pan : that we inherit from UI gesture recognizer, the abstract superclass. Okay, and pretty much all gestures want to look at this particular property that we inherit. It's called state. So the gesture system is a state machine. Okay, you all should know what a state machine is from computer science, and I'm going to walk you through the states. All right. So gesture recognizers, when you first add them, they are in this state, UI gesture recognizer state possible. All right, because nothing has happened to make this gesture not be possible. No touches have happened that are against the rules of this gesture recognizer. Then, as touches start to happen, it either goes to this state, UI gesture recognizer state recognized. If it's a discrete gesture, like a tap, like the tap happened, it's recognized. So you'll just get your pan : in that case it would probably be tap : and the state would be recognized, and you'd be like, yeah, my tap happened. Or if it's a continuous gesture, like a pan, then you get this UI gesture recognizer state began, and it's telling you, okay, this gesture has begun. And then as the continuous gesture happens, you'll get UI gesture recognizer state changed, and then UI gesture recognizer state ended when it's done, when the touch goes up or something else happened. Now, one thing is a gesture can start, and then the user does something else, puts another finger down, or lifts a finger that makes it so that, that gesture really wasn't happening. Okay? The gesture recognizer thought it was recognizing it, but something happened to make it, that didn't really happen. So you could get this UI gesture recognizer state failed happening. It means it failed. Okay? Or you can also get UI gesture recognizer canceled if it's a continuous gesture and the user does something to cancel it, to stop it, to not do it. The bottom line is, for most gestures, you're just looking for began, changed, and ended, or recognized if it's a discrete gesture like a tap or a swipe. Okay? So let's take a look at implementation of pan. All right? What would it look like? So this would be in my view, let's say, pan view. And the pan handler takes one argument, which is the gesture recognizer. Now, you can actually, for the discrete ones, you can actually have no argument here, just pan. And you would just say @ selector parentheses pan when you init the gesture recognizer. But here, we need the recognizer because as you're panning around, we need to be able to call that translation in view thing and find out where we are. So this one does take the argument. And you get to choose which one you want when you init with target. All right, so what's the first thing we need to do? The first thing we want to do is find out what state this gesture's in. Now, in our implementation of pan, we're only going to look at 2 states, and we'll ignore all other states. The 2 states we're going to look at is changed, so the pan has moved, or ended, the pan is done. And usually in a pan, that'd be all you're interested in. Same thing with a pinch, whatever, right? Because if it's canceled, or it fails, or it's just starting, there's really nothing for you to do. Hopefully you've already been following that finger around, and it gets canceled or something else, and it just gets left in whatever state it was in. So that's fine. So this is a common to only care about these 2 states, changed and ended. The reason I need changed and ended is, it might have moved a little bit from the last changed state thing to the ended, right? The ended, where the finger goes up, might be a little bit of movement. I want to catch that last bit of movement. So notice my whole method is inside this if. It's got to be one of those 2. So now I'm going to get the translation. I have this local variable translation, and I'm just asking the recognizer, which is a UI pan gesture recognizer concrete subclass, what is the translation in view myself? In other words, what's the translation, the movement in X and Y, that's why it's a CG point, of this finger that's been panning. So now I have the translation. So now I'm usually going to move something inside my view, maybe my whole view, but maybe only a piece of it, by translation.x and translation.y. Right? So I'm going to pan, move by a little bit. For example, let's look at an example here. Let's say I had a graph, okay? And I wanted the pan to be able to move the origin of my graph, for example. If I had a property on myself, which was my origin, which would be a good idea, I can just say my origin equals a point that is my current origin.x plus translation.x, my current origin.y plus translation.y. All right? And presumably when I call my self.origin, that's going to call my setter. It'll update my origin and probably call set needs display as well. And so, bam, my origin is going to move. Okay? And so now my graph is going to move. Okay? So that's an example. Now, here's an interesting line. Some people really don't like this line of code. They don't understand it, but it's super important to understand what's going on here. I am resetting the translation here to 0. Okay? And that's because the pan gesture recognizer accumulates the translation. Right? As you pan around, it's accumulating the translation. So, when you see the line above, translation equals whatever, I don't want the total amount I've panned. I don't want to move my whole graph that much because I'm moving it as it goes, right? So I only want the amount from the last time you called me. And so I'm resetting it back to 0 all the time, and then the pan gesture recognizer adds the translation that it accumulates, but now it accumulated from 0, and so now it keeps showing me the incremental amount that my pan is moving around. You see? Because I'm going to follow this pan around. I'm not just going to wait for the pan to all the way at the end, and then let go, and then jump. That would not be very good user interface. And in fact, if I was doing that, I wouldn't even be caring about sender.state equals UI gesture recognizer state changed. I would only wait for UI gesture recognizer state ended, and then I wouldn't even set translation view to 0. I wouldn't do that, but that's very unusual. Usually you're following the pan or the pinch around. You're following them in real time, so the user's getting feedback. Okay? Everybody cool with that? Any questions about that? Yeah. Yeah, okay. I might not repeat exactly your question. Maybe it's a little even broader question, but the question is when I touch down on the screen in a view, there's other views around. What if I put one finger in one view and one finger in another view? Okay, and then I start pinching. What really happens there? Or I put a finger in a view and then I move over and I move out of the view and into another view or whatever. And there are definitely rules for what happens there. And it's a little outside of the scope of this lecture anyway. Maybe we'll have a later lecture where we start talking about that because it's actually pretty cool the way it handles it. But for this class, the kind of views you're going to be building, either the gestures are going to be fully inside your view or not. You could check the API, the documentation, if you really want to jump ahead on that. It's not super complicated, but it's more complicated than I really want to go into at this point. All right, because I want you to have kind of a clear understanding of it. Yeah. Right. So his question is, drawing is very expensive relative to like allocating arrays and sending messages to objects and stuff, and that's true. Drawing is very expensive. Notice that I don't do any drawing in here. Okay. At best, what I do is in my self.origin, that setter might say set needs display. Okay. So I might actually, if it takes a long time to draw my view because I'm drawing a really complicated view or whatever, I might receive quite a few of these translation events, and they'll all batch up, and I'll keep updating my origin, and then finally it'll get through. So you're only drawing as fast as it can draw, right? Because you're not actually drawing inside here. You're just setting a bit that says, I need to be displayed when you get a chance, please. And so when it gets a chance, it's going to draw it, and then when it's done drawing it, it'll be back to listening for more events, and you'll get the latest event. Okay, so that's how the drawing part happens. Because yes, drawing is very expensive. Okay. Next. What are some of the other concrete gestures we have here? Pinch gesture is another common gesture. Its kind of concrete subclass special methods are scale, which tells you how much you have pinched out or in. Okay. Can't be negative because your fingers can't, go negative. They go down as close together and then out. If you spin around, it's always the distance between your two fingers. Notice that property is not read-only. So you can do the same trick here with scale. When you get a scale, you zoom your thing up a little bit, reset the scale to 1, and then the next time the scale comes in, you'll be scaling 1 up. So you'll be getting the relative amount of scaling. Okay? So we're going to see that in the demo today. And then there's another property, velocity, which is read-only, which is telling you how fast in scale factor per second it's scaling up and down. There's also a rotation gesture, which is 2 fingers rotating around. That rotation is in radians, also not read-only, so you could reset it to get the incremental and also the velocity of the rotation. There's a swipe gesture. Now, swipe gesture works a little differently. Okay, swipe gesture is discrete. It's not a continuous gesture. The way this works is you set up with the concrete gesture recognizer what kind of swipe you want. Do you want a single finger swipe that's only horizontal, or does it have to be 2 fingers swiping only vertically? You can specify the direction and the number of fingers required, and then if that happens, you'll get sent your pan colon. Again, probably you would call it swipe colon, and you would get that state, gesture.state equals recognized. And you're like, oh, my swipe was recognized. And then you go do something, right? So even though this gesture takes a little time to develop, it's discrete in that it either happened or not. You either happened to a swipe that had matched these 2 requirements or not. And a similar one is a tap gesture. Okay, number of taps and how many fingers. So a double tap with 2 fingers, you can specify that. And if it happens, you'll get this state gesture recognized. So the discrete ones are really easy to implement your handler. You're just looking for that state recognized. Make sense? I'm not going to show a demo of that, so hopefully it makes sense.
Is the swipe gesture often combined with dragging, like translating?
Yeah, I mean, the question is swipe combined with translating, panning, for example? And the answer is that the gesture recognition system is very complicated and complex when it comes to trying to figure out if you had a pan gesture recognizer and a swipe gesture recognizer both added to a view, it tries to make sure you get the right result. Okay? Whether, so if you, for example, if you have both and you kind of go slowly across, it's going to pan. But if you go rapidly across and lift up, it's going to assume you're swiping. So you see it has logic in there to cancel each other out. And if you could write your own gesture recognizers, that's very advanced usage, but in part of that API, you'll see that there's stuff in there for invalidating other gestures. It's like, this other gesture can no longer be valid because, we've gone too far down the path of it being this gesture, etc. So, don't worry about any of that for this class. That's advanced usage, but it is possible. All right. So, demo time. Looks like we got enough time to do our demo. let me talk a little bit before I do that about your homework, because when you watch the demo today, watch carefully and imagine your calculator, because that's what the homework's going to be, is to pretty much do what I do. This is every week, this is mostly true. Do what I do in lecture on your calculator. So the homework is to make your calculator work on the iPad. I'm going to make Psychologist work on the iPad. You're going to need to use a UI split view controller. I'm going to use a UI split view controller. You need to support pinching and panning and tapping gestures on your graph view. And I'm going to just show you pinching today. You're going to, and pan you saw on the slides. So tap is really the only one you're going to have to figure out on your own. And then we talked about NS user defaults way back when we first talked about Foundation. You will be required to save some stuff in NS user defaults, just because I want you to see how to use that. It's super simple. I'm not going to do that in the demo. It's so easy. And then next week, we're going to be talking about table views and scrolling views and image views. All right, so that's what's on top for next week. And probably, if you've seen the iPad, you see a lot of table views, iPod list of songs, those kind of tables of data. And so we'll be going into all that. All right. So any last questions before I launch into this big old demo? All right. And feel free to interrupt me, especially when I'm heads down typing. You might have to say, excuse me, or something to get me to look up. But feel free to ask questions, because you are going to have to do what I'm doing basically for your calculator. So let's jump in here. So I'm going to start with the Psychologist that we left off with last time. So let's go to Xcode here. Here's my Psychologist. I'm just going to open it. Let's hide others. Make her nice and big here. All right, so a reminder of Psychologist before we dive in here. It has 2 MVCs, just like your homework has 2 MVCs. One of the MVCs is this happiness view controller right here. All happiness view controller does is it manages that view with a face and a little slider to show the happiness. And then the other MVC we have is the Psychologist one. That's the one that puts the 3 buttons up. You know, how are you feeling today? And so we have those 2. And then we have this view, the face view. And you can see, remind yourself that it has this delegate method where it delegates its smiliness. That's its data. I know, very simplistic, but that's what all the face view has. And that's pretty much it. And I think last time we also looked at the application did finish launching with options here. And we created a navigation controller. We created the controller for our Psychologist MVC. We pushed that onto the navigation controller. We released it because we were done with it then. And then we just added that navigation controller's view to the window. Okay, so everyone back to speed where we were. So the first thing I'm going to do here is I'm just going to run this, and I want to show you something that doesn't work very well in this view. Okay, first of all, these buttons are kind of a mess, but we'll clean that up too. It is actually possible in the simulator to rotate, to simulate as if the user had turned it. And the way you do that is with this menu item in the simulator hardware. You see this rotate left, rotate right. So I'm going to rotate left here. Okay, well, our Psychologist didn't do very well here. You know, it's very hard to read this when it's rotated like that. And really what we'd like to do is rearrange these buttons so that the how are you today is along the top, and then the buttons kind of stack themselves neatly in the middle, but facing the right way up. Okay? So let's go into Interface Builder and talk about how do we do that. All right? Because we can do all of that for this particular MVC in Interface Builder. So I'm just opening up Psychologist view. Here it is. Let's make some space here. So first I'm going to clean up my user interface a little bit. It's kind of a mess. Let's make the buttons the same size, for example, like this. Oops, I got an extra button in there. Probably copy paste. So I'm going to spread them out a little bit, use the whole space. We can kind of really see what's happening when we rotate. All right, so here I have your user interface. I built it to be really tall and stretched out. It would obviously not look so good turned around. How do I make it all adjust to being changed? Well, mostly this is done in the inspector right here. This is the third tab over in the inspector. And let's see. I'll try this here. So, yeah, what's the problem here? I see. This is not opening. Okay. So this frame, this little ruler inspector, it has some mechanism in the middle there called auto-sizing. You see this auto-sizing area? And it's even actually showing us a animated demo of what's going to happen when the bounds of this view, of the super view of this view changes. So right now, you can see that little red dot. I'm selected this label right here. It's going to get stuck up in the upper left-hand corner. So when I rotate, it's going to be stuck in the upper left-hand corner. That's really not what I want. Okay, when my thing rotates, I want this title to stay in the middle, but I want it to be centered lengthwise. Okay, so the way I'm going to do that is I'm going to make it a little wider, and see how it's left aligned? That's no good. So I'm going to go to the attributes over here and center it. So now it's centered. Now I'm going to go back to this auto-sizing thing. And if you look at this auto-sizing, there's a black rectangle here. That represents kind of the bounds of your view, the bounds of the label. And you can see why it's sticking in the upper left, because I got this little I-beam right here and this I-beam right here. We call those struts. That means it's locked to that part. So I don't really mind it being locked to the top. And actually, it's probably okay if it's locked on the left as long as it's also locked on the right. But when I get bigger, I actually want it to stretch because it's going to be centered anyway. So that's what the middle is about. When I click the middle, that means it'll stretch vertically. And if I click the horizontal, that means it'll select horizontally. So now you can see how I've changed this so that my title is always going to be at the top, and it's going to stretch out and be the same distance from the two edges no matter what size my view is. So if it goes from being tall and thin to being wide, it's just going to stretch out and adjust. Okay? Then what about these buttons? All right, well, the buttons also look like they're tied to the upper left. That's really bad for the buttons. In fact, for the buttons, I really just want them to be spread out evenly in whatever space is available. So I'm going to have the buttons not be tied to anything. Okay, so I'm just going to turn off their struts. Okay, so all three of them. So now they're free floating in this view. And you can see in the animation, they kind of stay approximately where they are relative to the size of the view. And I'm also not going to let them be stretchy because I don't want these buttons ending up really wide with a small amount of text in them. I like them the width they are, and I certainly don't want them to get taller because then they'll look funny. So I'm not going to make them stretchy or anchor them to anything. Okay? So that's it. So by specifying the stretchiness and the anchor points of a few of my views, let's see if that looks any better. So let's go back to Xcode and run it this time. You know, the UI looks different only in that I made my buttons good shape. But let's rotate now and see what happens. So I'm going to rotate left. Oh, still didn't work. So I've done all this nice stretchiness. Why is it not doing that? And we actually covered this 2 lectures ago, or maybe it was the last lecture. It's this magic method, should auto-rotate to user interface orientation. Do you remember that? Right now, we don't implement that method. So by default, that method returns portrait only. So even though we rotated to a new orientation, our view controller is set up so that it doesn't rotate the views. So let's go fix that as well. So we go to our view controller. This is our psychologist view controller. And we just need to add this method. Hopefully it'll help me type it here. There it is. Should auto-rotate to interface orientation. And actually I'm going to say yes, which means auto-rotate to any user interface orientation. Okay, I could just return yes in certain orientations, but I'm going to return landscape, portrait, upside down, landscape left, landscape right. I don't care. So now let's run and see what happens. Oops. Yes with a capital S. Oops. There we go. All right. Run. Okay, same thing here. And now let's rotate. Oh, that looks better. Okay, now I might not like this. I might want the title to be a little taller, up closer to the top or something like that. And I can move things around. But at least it's rotating properly and changing the view and putting them in some kind of reasonable space. Now, you're probably thinking, oh my gosh, I have to do it with my calculator? You're kidding me. Because there's an awful lot of buttons in that calculator. All right? And frankly, you probably can't do the calculator view with struts and springs and having it automatically lay things out. Okay, it's just right now too vertically oriented of a user interface. Luckily, I'm not going to ask you to do that on the homework. Okay, you do not have to do that. You can try it. It's extra credit if you want to try and do it. It's going to require some code because I don't think you can do it. If you can do it with struts and springs, lots of extra credit. I'd love to see that, but I think it would be too difficult. But this simple user interface, we can. And our graph view, which just has the zoom in and out buttons, that one definitely we can do the rotate. And in fact, in this homework, since you're going to be doing gestures for zooming in and out, you're not even going to have the zoom in and out button. So you just have one view there. It's going to be really easy to make that thing rotate. Okay, it should just work by itself. You're just going to have to go in and set the stretchiness and the struts and springs of that thing. And actually, you're not even going to do that because I'm going to ask you in this homework to not even use Interface Builder to create the view for that controller, that graph view. Remember we talked about how to do that with load view. I'm not going to do that in the demo today. But that's how you're going to do it. You're going to implement this method load view, and it's basically going to return your graph view because that's all that's in that view. All right, so this is good, but now watch this. That doesn't look too good. Okay? He's not very happy, and understandably so, because he's so small. So we need to fix that view controller as well, so it doesn't do that. So let's go do that. That is the happiness view controller. So here we go. We've got these two views. There's our face view, right? And we've inspected it, set its class to be face view, so that's the face view. And then we got our slider. So what I'm going to do is I'm going to have the slider always stick to the bottom. Okay, so I'm going to say it so it always sticks in the bottom. And I'm also going to have it stretch out as wide as it wants and be stuck to both sides. That seems like a reasonable thing, right? And then the face view, I'm actually going to have it use all the space it can, all the way down, but leave room for that slider, like that. And the one other thing I'm going to do, I'm going to set my background, instead of having gray down there around the slider, I'm going to change that background to be the default, which is white, which will match our face view. And then the face view itself, I'm going to set its stretchiness. Well, it's already set the way I want it, which is I want it to stretch in both directions, and I want it to stay clamped to all the edges that it's clamped. So it's going to stay this far from a bottom edge. It's going to be clamped to this edge, clamped to this edge, clamped to this edge, no matter what size my view changes to. Yeah? So the question is, what happens if there's inconsistencies? Like I have a view that I say I want to stick to the top, and then another one that wants to stick to the top, and now when I stretch it out, how do they use that space or whatever? And the answer is they get stretched independently within their super view. So there's no there's no coordination between the views, so to speak. So the answer is you could get a mess. And it's your responsibility as a developer to set your struts and springs, and then test your app in all the orientations you're willing to support and make sure that everything lays out the way you want. And at worst, you might have to start resorting to setting frames in code to move things the way you want. I will say, just as a programming advice, is it's really nice to build views that are so simple that you can use struts and springs. Not just so you can use struts and springs, because it's better for the end user. Okay, the fewer things there are for the end user to be like, whoa, look at all these things in here, the better. Okay, simpler user interfaces are better. Now, if you have a user interface that's simple because it's the same thing repeated over and over, like the calculator, right? It's just all a bunch of operation buttons after operation buttons, well, that's still simple, and that's fine to have a lot of views in that case. But if you had a view that had all kinds of different views in there, doing all kinds of different wacky functions, maybe you want to put them on 2 different pages, right? And have a navigation controller navigate you over to a preferences page or something else. Keeping user interface simple. This is a phone. You got to remember, people got their phone out, they're tapping on things, they're talking to somebody, they're probably driving while they're doing it. You do not want lots of complicated things going on in there. It's just bad UI design on a small device. Even on the iPad, people are relaxed, they're sitting in bed, they're reading their book. They don't want to be going, tiny little control points. Okay? All right, so hopefully this will work. Let's go back to our app and run it. All right, I'm going to rotate again, let's say. Okay, dog ate my homework. Ooh, that looks a lot better. Okay, stretched out. This works. Everything's good. But there's still a problem here, which is this. let's rotate back. Okay? That's really not what we want. Okay? Our face always wants to be round, not stretched up like this. Okay? Why is this happening? The reason this is happening is that views, when their bounds changed, in order to reduce the amount of drawing, because drawing is expensive, they just take the bits and stretch them, because stretching bits is really cheap. You got a graphics processor in this phone, it knows how to take some bits and stretch it, and all you want. It's really almost just as cheap as not stretching them. But that's not what we want. We want our face to be round. So what we're going to do right here is we are going to override, well, we're going to set basically a property in our view which says when our bounds change, redraw. And you're definitely going to want to do this in your graph view, as you can imagine. All right? So watch carefully. So I'm going to the face view here. All right? Now, this is something I want to always be the case for this view. It's just always on. So I'm going to set this property in my designated initializer for my view, which, when you create a view, it creates one for you. Here's one right here. Right? It doesn't have anything in it yet. We didn't done anything. But I'm just going to take this line here that says initialization code, and I'm going to initialize it. I'm not actually going to type it here, though. I'm going to do the same thing I recommended last time in View Controller. I'm going to say self setup. Okay? I'm going to go up here. I have a method called setup. And here's where I'm going to do this magic. The magic is self.contentMode equals UI view content mode redraw. Okay? So content mode means what is the kind of content do I have? Do I have the kind of content that wants to be scaled or redrawn when my bounds change? Okay? So UI content mode redraw means whenever my bounds change, call my draw rect. It's like an automatic set needs display whenever your bounds change. Okay? So why did I put this in a separate method? Well, because initWithFrame is called if I alloc an initWithFrame my view, but if my view comes out of a nib file, then it's awake from nib. All right? Remember we talked about this last time. So I also want to have void awake from nib, and I'm going to call self setup from there too. Okay? So I just want to give you an example of what I was talking about. I was talking about it for view controllers on Tuesday, but it's also true for views. You need any setup code to be done with both of these things. Now, one other thing that I'm going to do here is to do the should auto-rotate. Whoops, not in view, sorry. In my happiness controller, I'm also going to put the should auto-rotate in here as well. Because, actually, here, I'll demonstrate this. Watch. Let's go back to our thing. So let's go back to psychologist. So here I am. Dog ate my homework. Okay, put a new view controller on there. Now if I rotate, it didn't rotate. And that's because the happiness view controller doesn't say should auto-rotate yes. Right? The psychologist one said it. And so it worked when we go over here. Oops. Sorry. When we go back to the psychologist and we rotate here, it works. Okay, so rotation works here no matter how much we rotate, but that's because we set this view controller should auto-rotate to user interface orientation. We always say yes. Well, we need to do the same thing in this guy's view controller. So let's do that as well while we're here. So that I'm going to do right here, bool should auto-rotate yes, all caps. And now when we run, we're going to have two things better here. One is, okay, we can still rotate here, right? And we go in here. This is round. And now when we rotate, it redraws it round. Okay, also, we can rotate in here, right? See how we fix those things? Okay, here's the one problem, though. Okay, so that's it. That's all I'm going to do on that. Let's talk about... question, sorry.
Well, since there wasn't the should auto-rotate before, how did it make that stretched out face?
Okay, we went back to the psychologist, rotated there, and went in. That's how. The question was, how did we ever get that stretched out face if it wasn't rotatable? And the answer is, we went back to psychologist, I rotated there, and then I went back in. Okay, and it re-rotated. So, there we go. So let's talk about the gesture. Let's go ahead and do the gesture recognizer here. So I'm going to do pinch on the face. I'm going to make it so we can pinch to make that face bigger or smaller. Okay? So to do that, really the primary thing I need to do, most of the code I need to write here, is just to have a property on my face view that's the scale. Okay, you probably, hopefully, have this in your calculator graph view already. So let's look in face view. Where do I set the scale? And actually, I set it right here. You see, I set the scale in my face view. I make it be 90% of the size of my view. So I'm literally just going to say, instead of 90%, self.scale. All right, and then I'm going to create myself a property, scale, which would be CG float, scale. And scale is just going to be from 0 to 1, or above 0 to up to and including 1. That's going to be our scale, okay, of this particular view. Your calculator is a different kind of scale mechanism, but we're going to do it this way. So I want property, CG float, scale. All right. Now, here's an interesting thing to note, and you may not have done this on your calculator's graph view, but it's a pretty good idea. It's a pretty simple implementation, which is I'm not going to synthesize this property. I'm actually going to implement both its getter and its setter. And what I'm going to do in the getter and setter is I'm going to make sure my scale has the right value. It has a reasonable value. It has to be greater than 0 and less than or equal to 1, right? My code doesn't make sense otherwise. I don't want to make it bigger than my whole view, and I can't be negative sized. So I'm going to protect the getting and setting. I'm going to protect the coming and going for the scale. And the way I'm going to do that is to implement the setter and the getter. So the setter is CG float scale. And all I'm going to say here is if, let's have a little method, how about face view, scale is valid, scale, then, and actually I'll even do something better than that. How about this? One line of code. Return, face view scale is valid, question mark scale. Otherwise, I'm going to return a default scale. All right, and let's define that default scale. Default scale, let's say a default scale 0.9. That's what we had before. We'll have it be the same as it was before. I like this to be defined. 1 pound. Okay, and then I need this little class method. Scale is valid. That's a really easy one. Bool, plus. Bool, scale is valid. CG float, a scale. And I'm just going to return a scale is greater than 0 and a scale is less than or equal to 1. Okay? Everyone cool with that? I just created a little utility class method there. Just takes a scale, determines whether it's valid or not. Any scale in there is valid between 0 and 1. And anytime someone asks for the value of my scale, including myself right here, I'm never going to return 0. I'm never going to return a negative number. I'm never going to return a number greater than 1. So this code is always going to work. Okay? Now let's do the same thing on the setter. Void set scale, new scale. I'm just going to say if this new scale is valid, then my scale equals the new scale. I'm also going to do something here, which hopefully you did, or maybe you did on your calculator brain, which is I'm going to say self set needs display. Okay? Because somebody changed my scale here, I need to redraw. Does that make sense? Why I do that? And this is a common thing. If you have a property on your view which controls how the view is drawn, then if someone changes it, say self needs display, so that the view will get redrawn. Okay? I could probably even be more efficient here and say if the scale is valid and it's not the scale I already have, right? Like I could go like this. If, well, I could do it. I have to do it before here. Sorry. If this new scale does not equal our current scale, then set needs display. Could do that too. That might be worth doing, actually. Drawing is pretty expensive. So if you can avoid drawing, that's good. Okay, so hopefully this didn't break anything. Let's run and make sure it didn't. Right? Dog ate my homework. Oh, it's still working. And default, I'm getting that default scale, 90%. But now I need to be able to pinch. So remember I said that there's, question back.
Shouldn't the update be after you set the scale?
No, okay, this is a very, very, very good question. Okay, so he's saying, oh, this is no good because I'm setting set needs display here before I set the new scale. But actually, that doesn't matter. Because set needs display just sets a bit that says, I need to be displayed. It's not going to get displayed until much later. Okay, you got to go all the way around the loop. Okay, so everyone understand why it's okay that we're setting the needs display before we do it? It does read a little funny, so I might, if I want to have it not read so funny, I could do this. Right, put the thing inside the if like that. Right, maybe that reads a little better, just so that someone who's not really getting the fact that net set needs display just sets a bit, looked at this and says, oh, okay, if the scale's not equal our old scale, then we set it to the new one and set needs display. That's good. Okay? But set needs display is not draw me right now. It's just draw me sometime in the future when you get a chance. Okay. Where was I? Okay. So our thing is working, right? We didn't break anything by setting that property. But now we're set up to be able to easily implement our pinching gesture. All it's going to do is set that scale. It's not going to do anything else but set that scale. All right, so let's do that. Let's write the handler first. I'm going to call it, I'm still in my view here, face view. So I'm going to call my handler pinch. Okay, and it's going to take a UI pinch gesture recognizer. I'll call this gesture. Okay, so there's my pinch gesture recognizer. The pinch gesture, remember, has a property I showed you on the slides, scale, which says the scale that the pinch is happening. So all I'm going to say is if my gesture's state is UI gesture recognizer state changed, or ended. Okay, so if it's changed or ended, that's kind of the same thing I did with the pan. I'm just going to follow this pinch until it ends. Then all I'm going to say is self.scale equals gesture. Times equals gesture.scale. So I'm going to take my current scale, and however much the scale has changed by, I'm going to modify it by that much. But I got to be careful here to say gesture.scale equals 1, because I'm going to get this called repeatedly every time it changes. So I want to keep resetting it to 1 and then have the new amount that it changes modify. Yeah?
If you forget the ended, does it just not do that last little?
Yeah. So the question is, what if I forget the ended? And I just said if gesture state equals UI gesture recognizer state change. Yeah, I just missed that last thing, which might not even be noticeable to the user. But, it depends how much lag there is, like how slow your thing is to draw and things like that. But the correct way is to do it this way, obviously. So that's it. That's all I need to do to implement the pinch gesture. But it still won't work. It still won't pinch because we have never in any of our code added this gesture recognizer to our view. So we need to do that. And that, as I said, we do in the controller. So happiness view controller is our controller. Here's view did load right here. It's a great place to put it. So I'm just going to say UI gesture recognizer. I'll call it pinch gr equals UI pinch gesture recognizer. I can't alloc init a gesture recognizer. I need a pinch gesture recognizer, a concrete one. And init with target, my view, which is self.faceView, and action, which is selector pinch, okay, which is the thing we just wrote. All right, and then I'm going to say self.faceView, add gesture recognizer, this thing I just created, and then I'm going to release that because I don't use it anymore in my controller. Okay, my view's using it all over the place, but I'm not, so I'm going to release it. Okay, everyone got it? Believe it or not, that's all we need to do. So let's hope it works. I didn't type anything wrong. So here we are. So now you might say, how do I pinch in the simulator? Okay, I don't have a touchscreen. And the answer is you can't really pinch, but you can simulate a pinch using the option button. So I'm holding down option right now. You see how it's showing 2 fingers there? And so you can move them around. They're not actually touching yet. And then if I hold the mouse down, now I can pinch. Okay, you can only pinch symmetrically around the center, but it's good enough for testing. So you can see this works pretty well. Okay, and the code, very simple. And really what made this code so simple is having that scale property. And really you want to think about views in that way. They have properties that modify the way that they're displayed, and you're going to have smart property setters and getters maybe, but you're going to get those properties set, and then it's up to your drawRect to draw that view with all those properties taken into consideration. Okay? You don't really have methods like on a view zoom to this location, and then there's a lot of drawing code in there. There's never any drawing code anywhere in your view usually except drawRect. The only other places would be methods you call in from drawRect, right? Like our draw circle method. Does that make sense? That's just that concept of UI view. Is that we drew all our drawing in drawRect, and we have all these properties that said how we do it, and then we delegate what we're drawing, like our smiliness or the graph data. Okay? Okay. So let's look at this though. Watch this. Go down here. Uh-oh. My scale. I lost my scale. Okay, I took my thing. I made it really small. I went to the psychologist. I went back. I lost my nice little face. Now it's big. Okay, why does that happen? Well, that happens because if we look back where we push that thing on, we actually create a new happiness view controller each time. We alloc init it, push it on there, and release it. And then when it gets popped off, no one has any ownership of it, so it gets released. And then when we click another button in Psychologist, it makes a new one. And of course, when it made a new one, it doesn't even know about the old one and its scale and all that. So let's change our Psychologist view controller so that instead of creating a new happiness view controller each time it wants to push it, it just has one, it keeps it around. Okay? And just re-pushes it, pops off, it re-pushes it, same one over and over. So let's do that. How do we do that? Well, there's a lot of different ways to approach this, but I love properties, you know me, so I'm going to make a property on my Psychologist view controller, which is my happiness view controller. So I'm going to say @sign property, and I'm also going to make it read-only. That way I don't have to worry about the memory management externally to this API. And I'm going to have a happiness view controller, and I'll call it, to be nice and verbose, make more chances to mistype something, happiness view controller. And of course I need to import happiness view controller in that case. All right, so I'm going to have this property. It's a public property. Anybody can get a hold of my happiness view controller. So, for example, they could get a hold of it and set the happiness. I'm allowing that. Okay? And my implementation of it, I'm going to do lazy instantiation. So here's my getter. I only need to do the getter because it's a read-only property. It's called happiness view controller. And I'm just going to say if we don't have a happiness view controller, I better get an instance variable for that. Make sure I type that. So let's go back to our header file. Forgot that. Let's go here. Happiness view controller, happiness view controller. Okay? So there's got an instance variable for it. So if that instance variable is not set, then I'm actually going to just alloc init one here. Equals that. Oh, alarm bells just went off at my head. I just typed alloc. Better release this thing. So I'm going to go down to my dealloc, and I'm going to say happiness view controller release super dealloc. Don't forget your super deallocs, everybody. All right, and then I'm going to return my happiness view controller. So this way I'm lazily instantiating it. I'm not actually wasting my time or memory creating one unless I'm actually going to use one. But then down here in our diagnosis, we just need to say self.happinessViewController's happiness is our diagnosis, and self.happinessViewController's title is the diagnosis title. In fact, I'm going to even change this to say diagnosis equals. And then we're going to push self.happinessViewController. And we are not going to release it here because we release it in our dealloc. Okay? Everybody cool with that? So let's see if that works. That should just work. All right, dog ate my homework. Let's zoom down, go back, and it's working. Even if we go to different diagnoses, let's stays small scale, okay? Because we're just reusing that thing, resetting its happiness. Everybody got what's going on there? Okay. The next thing we're going to do is, what are we going to do next? What's next on the hit parade? Okay. Next, let's do iPad. Let's turn this into an iPad app. Okay. This is going to be surprisingly straightforward, actually. The very first thing we do when we're going to create an iPad app is we're going to find our target. And this is right here under targets. I described this in the homework. It's hard to describe in words. It's so much easier to see visually. Here's our target. You see it says psychologist. That's our app. That's the target Xcode is building in this case. All right. I'm going to right click on that and do get info. So I right click on my target and do get info. Right. You can see there's this build stuff right here. If you have your target selected, and we're going to go set that in a second. If you have your target selected, you can go up here to project and say update current target for iPad. Now, we're actually going to create a universal app, so this is a little misnamed, but we're going to do it. So we're ready, everybody up where I am, here we go. It puts this up. Now, when you have here a choice between creating a universal application or two device-specific applications, we're going to do universal application. We're going to have one application built for both platforms. So let's say leave it on one universal, and we do it. Now, what did this actually do? Well, it did a little bit in that build menu that I was showing you, or that build window right here that I was showing you, and we'll look at that. But it also created a new main window.zib. So now I have two main windows.zib. You see I got that one, and then I got this iPad one. And that's because the main window on an iPad is big, and the main window on the other one is small. And don't worry, it automatically picks the right one depending on what platform you're on, so you don't have to do anything special. But we do have to go to this build window again. Back to here, right, get info. Here's the build. And there is one thing we need to do here. You can see there's two settings that are important here. One is this thing, base SDK. And this base SDK, I'm going to build in 4.1. That's what I have. I have iOS 4.1 is what's installed on this machine. So every time I build my app, it's going to use 4.1. Even though the iPad only runs 3.2, I'm still going to be building all the time in 4.1. So I have to be careful if I use 4.1 API to use response to selector or something to make sure I don't call that on the iPad. And then the other really important one is down here. You see this one? iOS deployment target. This is the operating system you're going to require on your target when it runs. And we want to set that, in this case, to 3.2. We could actually even go farther back because we're not using any. Well, we're using gesture recognizers, actually, so 3.2 is as far back as we can go. Okay, because gesture recognizers were not there before 3.2. So now when I build, it's going to allow me to run this all the way on 3.2 or later. I can run it on 4.0 devices or 4.1 as well. All right, so setting those two things, really important, okay? Setting the deployment target and the SDK. But once I've done that, actually, let's go ahead and run. What happens if I run now? No change, still works, right? But you'll see that I can also go up to here. This little button up here is very important. You see it? And now I have this choice, iPad Simulator 3.2. So I'm going to click that and press run. And now it's running it on the iPad. Only this UI doesn't look too good. Our struts and springs worked. Look at that. Stretched it out real nice. And this is not terrible. Okay, made giganto face here, which is good. I want the big face. Big slider at the bottom. I don't know. A little question maybe. But this is really not very iPad-esque. Really, in the iPad, I want both these views on the screen at the same time in a split view, right? I want my psychologist on the left, and as I'm clicking on how I'm doing, it's updating my face in real time on the screen, okay? So the next thing we're going to do is we're going to implement the iPad version of this instead of using an iPhone idiom, which is navigation controller, we're going to use an iPad idiom, which is split view. Okay? So we do that in the app delegate here. It's actually pretty straightforward. I'm not actually going to delete any code that's in there for the iPhone because I still need all of it, but I'm going to put a little, in the middle, I'm going to put a little, if I'm on the iPad, then else. And in the else, I'm going to put this, okay, make sure I'm still doing that. I'm not going to release my psychologist for a little bit because I want to reference it inside this if. But otherwise, I've just moved around and put some if there. Now, what about this method, self.ipad? I need to implement that. I'm going to make that a property. @ property. I'm going to make it public just for fun. It's read-only. It's a bool iPad. And let's implement that property. Implement the getter, bool, iPad. And the way you do that is this macro, UI user interface idiom equals UI user interface idiom pad. Okay, if that's true, then you're on an iPad. Okay, so what do we want to do on an iPad? Well, we want to create a split view. Okay, split view controller equals UI split view controller alloc init. All right. I'm actually going to put both sides, left and right, inside a navigation controller, just like I suggested a couple of days ago. My left side, the psychologist view controller, look, it's already in a navigation controller from the code I have on the iPhone, so I'm not going to do anything there. But I am going to create a new navigation controller, which I'm going to call right nav, and it's just going to be navigation controller alloc init. And in the right nav, I'm going to push the happiness view controller from that my psychologist view controller has. So I'm just going to say right nav, push view controller, my psychologist view controller's happiness view controller. Animated no, because we're not on screen yet. Everyone understand what I did there? We made a property that made my happiness view controller public, read only, out of my psychologist view controller. So I'm just going to grab it, and I'm going to put that in this navigation controller. And now I'm going to add, well, I'm going to do one other thing. I'm going to set the delegate of my split view controller also to be that right hand happiness controller. Because I remember I told you when you have a split view left and right, it's the right hand guy who has to know how to put that little button there when we rotate to portrait. Remember that? So I'm going to make the right hand guy, which is the happiness view controller, the face one, to be the delegate. And then I'm just going to set my view controllers equal to an array of my two things, my navcon, which is the one that has the PVC, and then my right nav. Okay, get rid of this extra thing that threw in there for me. And I can release both those navigation controllers now, by the way. Navcon release and also right nav release. Because I'm not using them anymore. I passed them off to the split controller. We're done. And then the last thing is I want to add subview the split view controller's view on the iPad. Right? The split view controller is a UI view controller. It has a property which is view. I'm just going to grab that view. That's the kind of the whole split view, and I'm going to add that to the subview, to the window as subview, instead of this, which is adding the psychologist view controller one. Is everyone cool with what I did there? So I instead of using a navigation controller and all that, I put in a split view controller. Now this is not going to quite work, but I want to show you in the way how it doesn't work. Okay, so this is kind of good. We got a face view, but in portrait mode, I don't have any button up here. Okay, if I rotate, I'm in good shape. I got both my psychologist, but it doesn't work because it's still trying to push. Okay, so this is kind of a mess. Well, there's two things we haven't done here. One, we didn't pay attention to our warnings. This warning says our right-hand happiness view controller does not implement split view delegate. So we better make that happen. So let's go over here. The way we do that is UI split view delegate. All right. And then in our implementation, watch what I'm going to do here to save some time. I'm actually going to look it up in the doc. Is it searching there? UI split view delegate. Oh, split view controller, sorry. Split view controller delegate. Okay, I'm just going to look this delegate up, and I'm just going to copy and paste this thing right out of here. So copy, and the hotkey, I have it bound to command equals, but you can bind it to whatever you want. So there's that one, and then we also need the other one, which is when the thing goes away, which is right here. Copy. Did I get the right one there? Yeah. Okay, so there's that one, and there's this one. And as I said before, these are really easy to implement. When the bar button thing, when the thing appears, all I'm going to need to do is I'm going to set that bar button item's title to be the other view controller's title. This is right out of the lecture slides. And then I'm going to have our own navigation items right bar button equal this bar button item. Okay, and again, you can look in the lecture slides for more detail there. And here it's going away, so I'm going to say self.navigation item.write bar button equals nil. So that's all I need to do in here. And then the last thing I need to do is where I push. That's actually, I got to fix this because I typed this wrong. This is controller. Okay, and then the last thing is where I push this in the psychologist view controller. I need to not push if I'm on the iPad, but I'm not going to check if I'm on the iPad. I'm going to check whether that face view thing, a happiness view controller, is already on screen. And if it's already on screen, I'm not going to push it. Does that make sense? Why I'm doing it that conditionally on that way? So that's right here. Here's where I'm doing the push. And I'm just going to say if self.view.window is nil, then I'll push. Okay? So I'm just going to make sure that my view's window, sorry, that's not really what I want. It's not my own view. It's my happiness view controller's view. Okay? So if my happiness view controller's view is already on screen, is not on screen, then I'm going to push it. Otherwise, it's already on screen, so I don't need to do anything. And I'm still setting its happiness. I'm even setting its title. So everything's copacetic there. Okay? So hopefully this will all work because we're almost out of time. So here we have our happiness view controller. It's on screen. Look what I have right here, a little bar button. It put it up there in the right bar button position. If I click it, there's our psychologist. Okay? And you can see that as I click it, it is updating. See that? And if I rotate, it's still working. Okay? So this is basically what you have to do for your homework, is put your thing in split view. You're going to have the graph view on the right. You're going to have your calculator showing on the left. One thing I might also do, and that you're required to do for your homework, is you see how this comes up and it's really, really tall? You don't want that. You'd want it to be smaller. So if you remember from the slides, there's a way to say how big a controller's view should be when it appears in inside a popover. And so you're going to want to implement that so that it makes a nice calculator-sized popover view. But otherwise, this is pretty much the way you're going to do it. Okay? So that's my demo for today. Right on time. So good luck with your homework, and we will see you next week. I will be here if you have questions.
For more, please visit us at stanford.edu.